welcome to The Explainer. Today we're embarking on a pretty fascinating journey to crack a secret code. It's a code that explorers, city planners, and everyday travelers have been relying on for centuries. I'm talking about the incredible, universal language of mapping the world. So let's dive right in and uncover how these remarkable tools actually work. It's a question that almost sounds like a riddle, right? How do you fit an entire planet into your pocket? Just think about it for a second. We take these massive, chaotic, sprawling spaces, we're talking entire continents, raging oceans, twisting mountain ranges, and we somehow shrink them down onto a single, perfectly organized sheet of paper. Or, the screen on your phone. How on earth is that incredible feat of compression achieved without just losing the reality of the physical world? Well, the answer, of course, is a map. Formally speaking, a map is a visual representation of an entire area or a part of an area, typically drawn out on a flat surface. But honestly, it's way more than just a drawing. It is literally the ultimate engineered solution for navigating our world. Whether you're looking at physical features like rivers and valleys, or political boundaries separating countries, maps are the absolute key to understanding exactly where we are and where we're going. Here is our roadmap for this explainer. 1. Decoding the map. 2. Distance and map scale. 3. Finding your direction. 4. The language of symbols. And 5. Reading the real world. Section 1. Decoding the map. Section 2. Distance and map scale. So maps really are a universal language. But just like any spoken language, if you don't know the vocabulary, you're basically just staring at a confusing jumble of lines and colors. To translate this visual data into a real-world landscape in your head, you need the right tools. And the first indispensable tool in our map-reading tool belt is essentially the magical shrink ray of the cartography world. To represent real distances accurately, mapmakers use a brilliant mathematical concept called scale. Scale is just the ratio between the actual distance on the ground and the distance shown on the map. It's the core mathematical rule that allows a tiny measurement on paper to flawlessly represent a massive distance in the real world. Without scale, a map is really just a sketch. But with it, it's a highly precise scientific tool. Now, I really want to slow down here for a second because this concept actually trips a lot of people up. It can feel a little backwards at first. When we need to show huge areas, like entire continents, we use what's called a small-scale map. It shows less detail because we're zooming way out. On the flip side, when we want to show a small area, like your local neighborhood, we use a large-scale map. Large-scale maps zoom in, providing way more detail like individual streets and buildings. So an easy way to remember it, small scale is for large areas and large scale is for small areas. Think about a simple ratio like 1 centimeter equals 500 meters. This is a classic example of a map's scale, which you'll usually find tucked away in the bottom corner of the page. If you know this simple ratio, you literally hold the power to calculate the exact real-world distance between any two places on that map. If your school and the library are 2 centimeters apart on the paper, you know for a fact they are exactly 1,000 meters, so 1 kilometer, apart in real life. It's really that simple, and it's incredibly powerful. Section 3. Finding your direction. Knowing the exact distance to your destination is great, but let's be honest, it's completely useless if you don't know which way to walk. Direction serves as our guide, orienting us in the world. And that's where the beautiful star-like figure known as the compass rose comes into play. Almost every map out there has a little arrow in the upper right-hand corner marked with the letter N. That's the north line. What's so amazing about this is that from that single known point of north, we can deduce every single other direction using the framework of the compass rose. Let's break this down cleanly. There are 4 major directions: north, south, east, and west. We call these the cardinal points. But to locate a place with pinpoint accuracy, we usually need just a little more nuance. That's where the intermediate points step in. These lie exactly midway between the cardinal points, giving us northeast, southeast, southwest, and northwest. By using these 8 points together, we can navigate super complex environments without breaking a sweat. Now, it is definitely worth mentioning that out in the physical world, stepping outside the margins of our paper map, we rely on a physical instrument called a compass. A real compass utilizes a magnetized needle, and because of the Earth's natural magnetic field, this needle is always going to point towards the north-south direction. So if you align your physical compass with the N on your map, boom, your piece of paper is suddenly perfectly synchronized with planet Earth. Section 4. The language of symbols. All right, so we've got distance down, and we've got direction. Now let's uncover a map's secret alphabet. This is an absolutely ingenious space-saving technique used by mapmakers all over the globe. Obviously, you can't draw an actual-size building, a winding railway line, or a sprawling forest on a standard piece of paper, so cartographers rely on what we call conventional symbols. These are carefully chosen letters, lines, shades, and tiny pictures. And honestly, here is the coolest part. There is an international agreement on how to use these symbols. That means a railway line or a post office symbol on a map in your hometown will look pretty much identical to one on a map from the other side of the planet. It truly is a universal language. And this international agreement doesn't stop at just shapes. It includes colors, too. There are universal map colors that you can always rely on. For instance, blue is almost universally used for water bodies like rivers, lakes, and oceans. Brown represents the rugged terrain of mountains. Yellow is used for elevated flatlands, which we call plateaus. And green? That designates low, flat plains. Because of this shared color palette, you can successfully read the basic geography of a map even if you don't speak a single word of the local language where it was printed. How cool is that? Section 5. Reading the real world. Okay, we've gathered all three of our tools: distance through scale, direction through cardinal points, and symbols through universal conventions. Let's see what happens when we actually put them to work on a practical example, like a map of Sundarpur village. Down at the bottom right of the map, you'll spot our north arrow, locking in our direction. Now, just scan across the area. You can easily pick out the blue line indicating a river flowing on the right side. You'll see green tree symbols scattered around, maybe showing some orchards or small woods. Notice the letters PS indicating a police station near the top, and PTO for a post and telegraph office. There's even a railway line marked super clearly in black and white right across the middle. By using our scale, our compass directions, and our symbols in total harmony, we can figure out exactly how far the police station is from the railway station and exactly which direction we need to walk to get there. So the big takeaway here is that maps are so much more than just pretty pictures. They provide a complete, information-dense record of facts about the Earth. By simply mastering these three foundational components, distance, direction, and symbols, these pieces of paper cease to be just confusing drawings. They transform into incredibly powerful tools of discovery that literally lets you hold massive landscapes in the palm of your hand. We've cracked the code together. You now have the vocabulary and the tools to translate the world around you. So the only question left to ask is this. Now that you know the code, where will your map take you? Grab a map, step outside, and go explore your world with fresh eyes. Thanks for joining me on this explainer, and happy navigating!